Hi, my name is Rohit, and today I'm going to talk about a little bit about adoption of data science in the journey to successful rollout of site reliability engineering. We are going to cover a little bit about site reliability engineering first, and a little bit about how data science can actually help in ensuring that the journey to the adoption of site reliability engineering is taken up. Uh, so before I start, let's take a step back and talk about a little bit on what is site reliability engineering. Yeah, what is it about, and how does it fit into what we think of and perceive of as an offshoot or uh, a superset or a subset of DevOps as a concept itself, right? So site reliability engineering is a concept which was first adopted by Google. Um, at a very broad level, I can see the difference is that well, it uses more or less the same principles which is used by DevOps. The only difference comes around, from an operation standpoint, more from a production-based environment where a lot of IT operation concepts come into picture more. So SRE is more aligned towards that part of the DevOps culture which we have. It also brings about the culture of software engineering and IT operations. As you know, I mean, more specifically, when Google did it, it was more specifically uh, examples which are given are from infrastructure operation side, but well, it can be applied across any operations with the primary motivation to provide reliability in the service which is being provided. Now, when I say reliability, well, reliability is well, you can measure a lot of you know key parameters and key indicators, but reliability is something which comes with time and which is and with age, and also services become reliable. It's very difficult to measure the reliability, especially when you are in a services based setup. It's very difficult to measure the reliability outside the KPIs which are defined, but it comes with time, with trust, and also with continuous engineering practices which come through. uh, and the SRE's focus is always, or site reliability engineering concept focus is always on end-to-end landscape setup to provide value while using uh, and moving similar setup to DevOps. As per the experience, it's one of the most expansive and fruitful way of doing transformation. It's primarily a cultural shift, and we'll talk about that in a little bit. Um, about how it is about cultural shift, how is it about measuring not what we call as service level agreements, but putting key objectives to make sure that the reliability of the service is intact. Okay, now before we start off that, let's talk about a little bit of problem statement here. Yeah? I talked about the SRE part of, you know, the conceptual part, but let's talk about some of the, some of the keywords which were used as part of SRE. Interrupt-driven approach is not something which is, which is actually inculcated by the SREs. It's absolutely the opposite of it. It eliminates interrupt-driven culture, obviously. Uh, how do we achieve it? Obviously, in a measured, proactive approach. There is a ritual of postmortem, which is about making sure, which is purely in academic in nature, and ensures that you know the best practices are followed throughout. Severity reviews are done effectively and efficiently, and there is a certain degree of observability attached with it, and also the chaos engineering concept which we have as part of site reliability engineering, which comes into the picture. We'll try to cover some of these aspects before we move to how data science can actually help us in doing some of these things easily, and how they are actually made for each other, the data science as well as the site reliability engineering, right? Now, when we talk about SRE as a transformation driver, right? So when I essentially talked about cultural shift, it is actually a cultural shift which creates a difference. It's about doing the same thing in a different way. And especially to add to the complexity, if we try to do a transformation, and usually transformations are a key aspect when either the organizations feel that they're getting stagnated, or the the competition is getting better, or we need a refresh, right? And the complexity is huge because in a monolithic setup of organizations, the change of these cultures setup is very difficult, if not at times impossible. Imagine organizations which have been running processes for 20 years, and all of a sudden you say, all right, let's disrupt this and try to do something different. This, for the services industry, it's quite different. Now, when the site reliability engine concept itself was brought in by Google, uh, well, Google is a product-based organization, and not all organizations operate the same way as Google, right? Uh, it's quite different if we get it up to a services-based organization. That will be the case today, which we are going to go through today, right? A services-based organization is quite differently set up compared to uh, an organization which is dealing with products, right? So we have standardization becomes an issue, because in services-based organization you have customers and customer units. Those customer units actually are sometimes so big that they start operating as a individual entity separately inside the organization. Uh, there are questions which come up as to why should I follow the standardization process? Why should my process change with others? And why should I get into the clumsy part of trying to do the standardization, and so on and so forth? Risk tolerance of the service, obsession of the contractual agreements, vary from customer to customer. So getting all of that into one box is a difficult job, right? Then there is an aspect of process, and a process we already touched about, of automation. Now, automation is one of those overused terminologies in the industry. Uh, a lot of people are under the, I'll be very honest in saying, wrong perception that automation is going to solve all the problems, right? Which is not the case. Automation is just an end product. It's the end product after doing the analysis. All right, we have reached here, we want to do this, and based on this, we are going to get some tangible benefit, which could be, um, you know, uh, reduction in doing mundane tasks, or reduction in effort, or whatever. That's We'll talk a little bit about that as well when we talk about automation, because the SRE has 7 principles, and automation is probably only one of those 7 principles. There are much more than that which are required to be looked into. Then we have the technology refresh part of things. Okay, so now technology refresh part, well, with time to time and coming of age of open source tooling, has moved a lot of these monolithic organizations into thinking, how do we do it, right? And there are challenges. You can't break down the wall in a day and start building up again with new tooling. Okay, there are contracts involved, there are services involved, there are livelihoods involved with all of that, and it sometimes becomes a very difficult job to do when it comes to the transformation part of things. Now, the fourth and the most important thing which we are going to discuss today in detail is about making use of operational and component data analysis, right? And we're going to talk about uh, how this part of data analytics can be used to really kickstart, drive, and push the site reliability engineering concept across the organization. We also talk about a little bit on the visibility engineering part. That's what we call as the visibility engineering, where we have a situation where an organization has to get to a mold of doing visibility engineering, where it is about having one common unified data source and using usage of data science to look at things which are not really visible from the naked eye. So, from a visibility engineering perspective, the important and the key message is, how do you set up your site reliability engineers in the organization, right? This is from the example which we have been going through as an organization ourselves. Uh, since it is a services based setup, we are not in a position to have one open structure on top and say, yeah, these are the 5, 10 brilliant SREs which we have in the organization. Now they are going to dictate and everybody is going to listen to that. That's not going to happen in services based organization. It can still happen in a product based organization, but not in a services one, because of obviously reasons which we discussed some time back. Yeah? So what do? We put up a concept of a vertical and a horizontal SRE. Yeah, the vertical SREs are the SREs which are embedded into each and every tribe, each and every service which is provided by the organization. Can be same service across different customers, can be different services across the same customers, but we do have SREs at all areas, right? But they have to be governed, they have to be nurtured, they have to be put on the right path, as well as sometimes handheld. And for that to happen, there has to be a massive drive of horizontal setup, which we call as bootstrap. You can see in the diagram, uh, which is a bootstrap team, a very thin layer of best site reliability engineers in the organization who actually drive this shift and do the penetration. Why do we have a vertical base setup? Because we need maximum penetration in the organization. Then only the culture will start changing. We cannot have only a horizontal on the top and ask the guys to just follow it, right? That's number one. Number two is also making usage of data as a key source, or I should say, data driven decision making. It's not a concept which is new, but now with age and with time, we have come to a point where we have tools and technologies which can actually help us drive this in the direction of using AI, machine learning, and you name it, all of those techniques to get to things which can be perceived much before in hand. We'll talk a little bit on that. Now, let's talk only about the data part of it. Well, data is the new oil, right? And organizations, especially the operation-based organization, people who talk about the production part of things, are obsessed with ITSM data. When we say ITSM data, it's IT, service management data. Uh, People love analyzing tickets, love analyzing incidents, changes, you name it, from an ITL perspective, right? Now, there are different ways of looking at data. Now, first stage obviously is analysis of ITSM data itself. There are tools, processes. ServiceNow gives a brilliant, uh, framework for doing all of this. And the way we started was we started applying a lot of machine learning concepts into the ITSM data. The reason for that was the ITSM data can actually start providing you the problems. Now, most of the traditional analysis is done based on looking at where the problem is. Okay, like, oh yeah, I see a lot of tickets here, so there must be a problem somewhere there. Or, oh, I see a delay in this because we see a flood of tickets coming in here and there. Those are very rudimentary, right? They're good, no denying that fact. They're pretty good, and it can provide some part of the analysis, but that's not the real part of the analysis. The real part of the analysis only comes to the point where we start telling not where the problem is or which area the problem is. We start telling what the problem is. I'll give you an example. Simple example is 400 or 500 million tickets coming in a year, and with no proper descriptions and not proper categorization in place, it becomes a Herculean task for somebody or an SME or an SRE to actually look at what is the technology issue behind it rather than just going through the Excel. Now, the idea is not to bog down or overwhelm the site reliability engineers with data. We have to provide them and take a feedback from them and make systems which are going to make their lives easier. Means provide them where the problem is and also what the problem is. So if at runtime they can start looking at technology issues which are coming in based on the tickets which are coming, that becomes an issue. That becomes a solution, and that is something which has been implemented based on historic data. So you do the categorization, right, the logic, right, the code, back test it with years of data to get the accuracy right, so that at runtime they actually see what is the technical issue happening. That's the first step. We call it the first stage of using the data directly. The second stage comes where we get to a point where we are not no more going to use any of this IT operations data. We are going to start using log data, component-based logs. Okay, could be server, could be database, could be you know a device, could be any of it. Right, generates a lot of logs. The component logs are a gold mine, which, if analyzed properly, can show things which you can never see by doing any other sort of analysis. And this is where the concept of dynamic thresholds and predictions come in, right? So we have a situation where ITSM provides you brilliant monitoring setup. Okay, they have thresholds, static thresholds. By the way, monitoring is one of the very key principles of SRE. So uh, we call this more from an advanced monitoring perspective, the prediction part of things. But ITSM actually takes care of static thresholds. We'll give a very simple example. You have a threshold of 80, 85% set up on your device. The moment we see a utilization going above that, it just throws up a alert, which can be converted into an incident or a ticket, and people, try solving it. Those are static alerts, right? Static thresholds. We're talking about dynamic thresholds. We're talking about predictions. We are talking about taking the data for, uh, you know, 60 odd days, using the 45 days data as the base data, and doing a prediction for next 15 days, and looking at how your component is based on the history. How are they going to behave? What will be the different parameters which are going to go through? Just to give you an example, um, a virtual machine, okay, has close to 30 odd parameters which can be logged at an interval on time series based setup fashion, right? If we can get a correlation of that, and that's something which we have done, and also look at how one parameter is dependent or independent with the other, and then go for a prediction for some of those parameters, you can actually go to an extent where you can start predicting the infrastructure failure itself. Okay, where you have a dynamic combination of looking at more than one parameters and saying, all right, five of them are showing a dynamic threshold breach, we are on for it, and we expect something to go wrong in 8 hours. Now, that is going to be a very potent tool. It's not easy to reach, and it's mathematics. Let me be very honest. Maths can fail. It's based on mathematics, right? But at least it makes you proactive. That's one part of it, right? And we talked about different data coming out of it. And this prediction has consequences, which I'll talk about further later, right? The third part is data is democratized for everyone to use. We need to put up a structure in place which we call as unified data layer, which we have put in place, and that's the architecture of that, where we have different data sources from an automation, cloud native infrastructure, you name it, files, put it into a data ingest layer with the logs, metrics. You have the raw data, you have the system data, you have the service data, you have all of it, ITSM, non-ITSM, component, non-component, prediction-based data, log-based data, everything in there. And then you have the service discovery with the plugins of monitoring API, config, and repair API for the automation, obviously, in the system. Uh, Machine learning models can be anybody who wants to make ML-based models can use this unified setup. Obviously, we use Kafka for doing the entire streaming inside, and data sharing process and data visualization processes all there, in there. So basically, the idea is we want to give this power to everybody to do this visibility engineering setup, right? Now, it's easier said than done. I will not say that we are 100% there, but this is the idea. This is the idea of using different tooling aspects, monitoring, making sure we take data driven decisions, and based on that do the automation, which is the final step. Before I go to the measurement and the working part of things, we talked a little bit about predictions, okay? And this is something which we are trying to do today, okay? uh, which is the second point in the slide. Now, proactiveness can go up to, has no limits and no bounds, right? Today's ITL process, when it comes to operations, is actually very much based on, uh, you know, problem management, which is very reactive. Now, the point is, things have happened, and then you start looking at and doing a root cause analysis of what has happened. That's the ITL process versus the new prediction-based model, where there is no concept of called incident management or alerting. Okay, there is no concept itself because you have predictions in place, and accurate predictions will tell you, for example, 8 hours from now, I expect the system to go down based on the predictions, right? Now, what are we supposed to do? Our entire ITL, 95% of the industry follows ITL using incident management approach, where we have static thresholds and people look at 85-90% and then start taking actions. Here we are in a situation where mathematics is telling us, and when I say mathematics, I mean data science, is telling us that we are going to go wrong in 8 hours. So, what are our actions? How do we do a proactive problem management? And that's where we have brought in a unique concept of SRE leading a team for 80% of the threshold, which we see. For example, if it's 8 hours, we look at 6.5 hours to ensure that the problem is solved before actually the problem happens, which is 8 hours from now. Uh, this is still under construction. I mean, it has been piloted, adopted in some areas. Some areas we are facing challenges because of the processes in place, because of the customer nature, because of a lot more variety of issues which we have and the challenges which we have. But this is the future. This is how we are going to go, where data science actually starts taking over a lot of these tasks from an IT operations perspective, and SRE is going to spearhead it because they are the ones who actually know what is meant by reliability and what all things can be, best about it. Uh, but still, the adoption is lower, but it is the way going forward. People are really having an obsession about ITSM based analytics, and they call it the analytics, but that's just the tip of the iceberg. We can go much, much more than that um, in future. Now, that's the part of the old and the new proactive problem management, which is also another very key aspect of site reliability engineering. Now, the next part is about error budget. Now, what is an error budget? It is one of the key, uh, I should say, parameters or principles of site reliability engineering. When I say key, it means it's about measurement. It's like giving you an example of a lot of people like running or cycling, right? Which is excellent, good for health. But they do have these devices now, or smartwatches, which they wear to just monitor how they are performing, what's happening to different parameters of the body. It's the similar concept. Why do we do it? Because we look at our improvement based on that. This error budgeting is exactly meant for that, to look at how better we are getting, how reliable we are getting as a service using SRE, right? And the measurement of error budget is about not following what we have as contract, in the sense we have an SLA and we have a contract with the customer, and we don't want to breach it. No, that's KPI management. This is about defining objectives to ensure that the reliability is increased. There are various factors which can do it: doing it quicker, doing it with better quality, and doing it proactively. Either of it, if done correctly, if properly, will take us, all of us, to what we call as reliability, right? And that's the principle for SRE, and that's where data science plays a big role. Just to give you an example of defining SLOs based on calculations, which relates to reliability, we have a situation where we have a setup where, yeah, we do a lot of incident management, problem management, and all of that. But customer feedback implementation is the right core of it, right? A very rudimentary example is password reset. Yeah, a password reset at times can be a zero operations approach, can be applied, right? You have a chatbot, you can put it in, and then just do it, right? It's extremely reliable, but contractually we are said that we have 8 hours to do it. And if somebody raises a password request, we have up to 8 hours or 5 hours to do it. But in reality, it can be done at real time. In fact, a human is also not required at times, okay, depending on the complexity of the systems which you have in place. But we are contractually obligated for 8 hours. Now, this is where the customer part of things comes. This is where the reliability part of things comes, right? We can put in an automation, put a chatbot, it will start doing it. What if it fails for some reason? Okay, that's when the reliability is questioned. That's where you look at the resilience of your system, okay, and that has to be calculated. So if we see a, a technology or a business process which has a capacity to be improved, we define SLOs, which will be obviously less than the SLAs. SLO is service level objective, or SLI is also, so a lot of people call from an indicator standpoint, where we define a much lesser, turnaround time to increase our throughput, at the same time providing reliability. And we have a setup of what we call as error budgeting based on those. Uh, so a team is allowed to put any sort of automation or make system resilient as long as they do not breach these SLOs which have been defined. So, for example, if the SLO is say 60% of SLA, they're not allowed to breach it. And every time they breach it, okay, they'll have a deduction of what we call as credit points of -1. And the day that credit point reaches 0, any sort of changes which are what I call bold in nature are stopped for that particular team, and they have to go through entire quality gate process before they can do it again and show the credibility again, right? The same happens when we do the change management. The change management has a window or a SLO defined, which is much less than SLO. And if that is breached twice in a quarter, all the all the automations which are provided by the team comes under scrutiny, and they are not allowed to go ahead without doing any quality, without breaching any quality gates. Now the reason for that is, what it does is it also takes care of one of the key aspects of SRE, which is about ability to take risk. We provide a mechanism based on the error budget, where people are free to do whatever they want from an perspective of reliability, putting new automation, new tooling, or whatever. But that's measured. If we breach that measurement based on the credit points which I discussed earlier, they have to go back to the old setup and then do a proper root cause and come back as to what will be the improvements, and then only they get their credits back. And that's how we define the error budget concept on defining SLOs from the system. Okay, this was the last slide, but I did not put in a slide for what I call as challenges, but I would like to, briefly talk about these challenges of both the aspects, the site reliability engineering as well as what we call as data science usage. There are consequences behind it. Instruments of gratification, that's the first of challenges, right? You do any sort of transformation in a monolithic setup, people look for fruits quickly. There's no easy way out for this, and it's a cultural shift along with a lot of things which you have to do to ensure that you are rust proof. Going a transformation is done to an organization to make it rust proof for years to come, right? And that's why instant gratification is not something which you'll get here. Principal adoption culturally, yeah, we talked about it. It's going to be challenging because you're trying to change the system and ways of working. To ensure that it is in the proper setup, a lot of people put in heavy governance, which is also a issue for us, because too much of governance actually, or too much of structure actually, doesn't allow you to do a certain degree of innovation. Uh, GDPR, data usage, data privacy, moving all data into one, having accessibility, it becomes an issue. It has been a major issue for our rollout, to be very honest. Uh, Empowerment to take real decisions. We have to be standardization, but we know also we should also be cognizant of the fact that standardization has limits. Not one size fit all will work everywhere. So we have to be open to take that decision, and you should be empowered enough to do it. And in my view, if I can be very honest, standardization is a little bit of an illusion. There is no 100% to it. You can reach to an extent, but not beyond that. So reconciling what we talked about, site reliability engineering is one of those concepts which applied to the production systems or IT operations can do wonders. Data science is going to give it potency and the the uh, the edge which is required to take it to the next level, and it's already happening. Okay, and the data which comes out of the components are the key data where we should apply actually data science, because those appliances and components which are getting those data out, the logs which are coming in there, they are really a gold mine. And if we put a proper strategy in place to start using it, uh, you can see differences almost immediately in how your performance is happening for an organization or a transformation as such. So before signing off, let me quote um, a good quotation which I got. The key to change is to let go of fear. The more you try new things, the better it's going to be. Thank you.